This is my code demonstration for Prog 7312 Part 3 or Task 3, the final POE part. So, firstly, I will guide you through the back end, how the code works. Then I will show you a flow of how the front end works. So to start off, I'll start on the AVL tree. So basically what my AVL tree does, it represents a self-balancing binary tree that stores key value pairs. So firstly, just to note, all code references are on the GitHub. So if you want to see where I got my implementation from, it's all on the GitHub. So the AVL tree was just a self-balancing binary search tree that stores key value pairs, and then it supports insert, delete, finding operations with the O of log n time complexity, and then it just maintains height balance automatically to ensure that um, fast searches and transversals, and then it also provides in order transversal to retrieve um, all stored items in sorted orders. And then also it's used for storing service requests. So that's the main part. So they can be retrieved or listed in an order. So over here is the transversal, the insertion, the deletion, finding in order, the balancing to make sure that the left and the right are balanced, and then to update the height to its children. Then I will go on to the set graph. So with the graph, it firstly is a node class that represents single nodes in a graph with a unique identifier in a collection of neighboring nodes and edge weights. So here is my unique graph. Um, so basically, this graph just represents the whole graph using adjacency set. And then it supports adding nodes and edges, retrieving neighbors, graph transversals using breadth first search, and then depth first search, and then can be directed or undirected depending on the type of use case being used. And then so basically what the AV the the adjacent set graph was used for was just to track dependencies between service requests and display that to the user. So just to see what tasks depend on each other. Then my other data structure was a heap. So the heap just represents priority based sorting for managing items based on custom priority. So this function. So it just supports adding items, removing um, the minimum or the high priority item, and then peaking at a top item. And then it just maintains the heap priority using heapify up and down. So the heapifies up and down, and then it, basically it'll just convert the heap into a list that's sorted, and then it's used for sorting service requests by priority and creation times. So that's what the main part of the heap being used in the application for. So when displaying to the user, it will first display based on priority. So high priority will be first, and then it'll be um, also based on time. So if a request was made before another, that before request will be first. So it's ensuring that um, a first come, first serve is done when it comes to priority. Then here's just my controller. So over here, I initialize just my service request, my AVL tree, and my graph. So these are the ones that store the values, and then create dependencies. So over here, I just seed data, and then in the index, I just display service requests with optional filters and do a priority based sorting using the heap. So over here, and then I have a track. So here's just to go, so displays all dependent requests for specific service requests using transversal of the graph. And then here's just the data that gets seeded into the application. Here is inserting each node and then adding dependency edges to each uh, node. And then here just retrieves and requests from the AVL tree, returning a Boolean of existence. And so overall, the controller is just the main heart of the code. So it's the main um, it's the main work that the code, this the main functionality for the website. So if I had to execute, uh, okay, I already had it open, but here will be a home page, and then the user will, so these were the part one and part two code, and then this was service request. So as you can see over here, the items are arranged by priority first. So it's firstly high priority, then medium, then low. And then if you look at the dates, it goes 7th of November, 8th of November, and then 10th, and then 10th. So it goes in ascending order so that it checks what high tasks should be done first. And uh, so it checks what priority needs to be done first, but still working according to a first come, first serve basis. And then over here is just using the sorting to get high priority tasks only on the side, just to make it easier. So a user can additionally track a request. So they'll just come into it, they can see the dependencies and then the status and then whatever the details were. So if I were to show searching by an ID, you can check by one, track the request, and then here's the request with its dependencies. And then if I had to go back, um, and then search by a title, so let's say water. Here I have three water tasks done. And then if I track the request, these are the dependencies for each other. So fixing the main pipe is the 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 main task, and then these are dependencies because you can't fix the water at school A and house B without fixing a main water pipe if there's no water anywhere. And then just for additional visibility of how each of the dependencies work. So I created a graph to visualize how it looks. Um, so there's a key over here. So if it's red, it's high priority. If it's yellow, it's medium. And then if it's grayed out, it's low priority. So if I had to show the water, fix main water is 1, repair water is 2, and then repair water at house B is 3. So if I had to look at request one, two, and three, they are um, defined over here and they show their dependencies on one another. And then similarly for these requests, so request four being cleaning the park, and then request eight being trim trees on the main street. So all of those tasks lead hand in hand. And then these tasks are also dependent on each other. So if there's a task that's not dependent on another one, it just will show it alone over here. And then when you go into it, so let me showcase. Uh, so if I had to come here, add a new service request, 14, um, clean storm drain on 6th Avenue. We will put this to medium and we will keep that. And then uh, as you can see over here, the request is alone. It doesn't have any other dependencies to go along with it. So if I go to 14 and check the request, there's no dependencies for the specific service. Thank you very much. This was my code demonstration.